The problem states if block D weighs 300 pounds and block B weighs 275 pounds, determine the required weight of block C and angle theta for equilibrium. All right, so the first thing we need to do with regard to this problem is understand that we are in equilibrium. What does this mean? This means that every single object you see here is stationary. This means that acceleration is equal to 0. Equivalently, this means that the total summation of forces in every direction is also 0, because we know that force equals ma. And the summation of forces, if acceleration is 0, is equivalent to 0. Now, given that we know the summation of forces is 0, let's draw some free body diagrams to inspect these elements. To start off, I'm going to draw a free body diagram for location A, because it is very central and intuitively seems to be significant. So this is our point A. We have a rope here going out, a rope here, and a rope here. We know that these ropes are in tension because there's an object here suspended, here, and here. Given that the ropes are in tension, we can represent them with vectors. So this is our first vector. So that is this rope. This is another one. And this is another one. It is very important that we define our axes. So this is the y-axis, and this is the x-axis. Now let's label these vectors that we have drawn. I'm going to call this one t sub c because it goes to object c here. I'm going to call this one t sub d and t sub b. Let's add every single piece of information given to us. So let's extend this horizontal axis here. The angle between the horizontal axis and t sub b is theta, and the angle between t sub c and the horizontal axis is 30 degrees. Now let's determine what all these vectors mean. So we're going to need to draw 3 more free body diagrams for each of the objects here, because they are suspended on their own ropes, which are these 1, 2, 3 ropes. So this is for object B, this is for D, and this is for C. And our axes for this these 3 free body diagrams is Y and X as follows. So we know the weight of B, so we'll call this W sub B. We know that it is connected to T sub B because it's so let's trace this line. B is connected to this rope that goes around the pulley and goes here. As we can see, that is this vector. This has the same magnitude as this. The only difference is that they have different directions. Now, looking at this, we can say that T sub B is equivalent in terms of magnitude to W sub B, which is the weight of crate B, which we know to be equivalent to 275 pounds. This says T sub D is equal to W sub D, and T sub C is W sub C. So let's write those out. T sub D is W sub D, and T sub C is W sub C. Now, when you get experience with these, it will be absolutely pointless to draw out these free body diagrams. In your homeworks as well, it's very worthless to draw this out because it's very evident that something that weighs 275 will put a tension in this rope that is equivalent to that number. This happens because there is equilibrium. However, I just want to write those out to ensure that everyone sort of understands why this equivalence is in place. So let's see what else the question is saying. It says 300 pounds for the weight of D, so then TD is equivalent to 300 pounds. And now all we need to do is determine the required weight of block C. So T sub C is the unknown here. Now that we've established that, all we need to do is solve the equilibrium problem. Let's set Fx, the summation of forces in the x direction, equal to 0, which is equal to T sub C times cosine 30 degrees minus T sub B times cosine theta. And equivalently, let's do this for the y-axis. This will also equal 0 due to equilibrium, which will be minus TD plus T sub B times sine theta plus T sub C times sine 30. So let's simplify this a bit. We know that this is equal to square root of 3 over 2. We know that this is equal to 275. This is also 275 and 300. Oh, and also 1/2. Now let's rewrite. We have T sub C equals 275 cosine theta times 2 over square root of 3. And also we have T sub D equals 300 minus 275 sine theta times 2. Oh, I don't know if I said T sub D, but I meant T sub C. So T sub C. When we do basic algebra on this expression, we get that theta is equal to 40.9 degrees, and the tension in the rope that suspends crate C, so this crate, the tension in this rope, which is equivalent to the weight of the crate, we see that the tension is equivalent to 240 pounds. Again, you get these values when you solve this basic algebraic expression.